In this video, we're going to be talking about the charging and discharging of a capacitor. Now, how is a capacitor being charged and how is it being discharged? Okay, now you can see a series of diagrams on the board which will help us derive the equations that we use in charging and discharging a capacitor. Mind you, in our previous video, we talked about charging, we talked about capacitors. I also talked about the uses as well, okay, and the various types of capacitors. Okay, now we also said that a capacitor is a battery, or a battery is an example of a capacitor. So when you're charging a battery, the equation you are going to be required to use, or the equation your battery uses to charge, is what we're going to work now derive here. Also, when you're discharging a battery, that is when you're using it, okay, the equation we're also going to talk about it. So that diagram will be for discharging, and this one is going to be for charging. Now, first things first, to charge and discharge a capacitor, we need first of all a resistance. Okay, so a resistance must be involved when charging a capacitor. It is what helps to charge it. Now, I'll be deriving the equations that are useful for charging a capacitor, and then we'll move on to discharging. Okay, in the RC circuit. So when it contains when we're having a capacitor and a resistor, it becomes an RC circuit. Okay, so here is still the positive and the negative side. Now, here will just happen when we are charging the capacitor. First of all, this is an open circuit, so we've not started charging. You can see that the key is open, it's not touching any of these points, either A or B, so it's open. Now, for us to charge this, we are going to close the key down to A. Okay, immediately we close it down to A, current will now start flowing in this word now from this cell or battery. You can see this is the positive side. This means, okay, let's assume the current is going to move like this. Now we're going to apply what we call Kirchhoff's law. Okay, it is something that is in some other of our videos. Okay, it is in some of our videos, so you might want to understand the law before getting into whatever I'm going to do here. I'm just going to make use of the KVL, which is Kirchhoff voltage law, okay, on this aspect. So if we are moving in a clockwise manner, it means we are going to have E, which is the EMF of the battery, okay, minus the potential difference of the capacitor, okay, minus I times R, which is the potential difference across the resistor, equal to 0. Now I can choose to make IR subject formula here. If I choose to make IR subject formula, I'm going to get E minus VC. Now mind you, at a time t, the value of the charge on the capacitor is 0. Okay, initial time, at initial time t equal to 0, the charge on the capacitor is 0. It is immediately we close the knob, that is this keyhole, that charges starts flowing, okay, and it starts building up. Take note, charges cannot jump from this place to this place, okay. They only get transferred due to the electric field that is built up between them, but they cannot jump because of the space, okay. So this is what we're going to have. IR equals E over VC. I can choose to make I the subjects. I'm going to get I is equal to E divided by R minus VC divided by R. Now, what is the formula for calculating the capacitance of a capacitor? Okay, we know that the capacitance of a capacitor is charge divided by the voltage, right? We know that the capacitance of a capacitor is charge divided by the voltage or the potential difference. Or we could as well say that C is equal to what now? CV. Now, after we are done charging, okay, when it gets filled up, when this capacitor gets filled up, what we'll notice that E here will be equal to the potential difference, which is VC across the capacitor. That is, E becomes equal to VC. So when it is filled, we now have a maximum charge, and that maximum charge we are going to represent as Q naught. Okay, maximum charge we are going to represent it as Q naught. So Q naught will be equal to C times V becomes what now? E. So you notice the difference. Before it gets filled, VC, which is in this case VC, will be equal to Q over C when I make this a subject. But once it gets filled, Q naught becomes equal to what now? C times E. If I choose to substitute these two equations, into what we are having here, we are going to have, and also I is the Q over the T. That's something you should take note of. So no, I is the Q over the T. Okay, so I'm going to come here and I'm going to write the Q over the T is equal to, now E is what? E from here is Q over C. So I'm going to have Q over C multiplying the R at the bottom minus what is VC? VC from here is Q over C. Okay, so I'm going to have Q over C multiplying the R at the bottom. Okay, this E It's Q naught, not CQ rather. So we're going to have Q naught. Please do not make the mistake. Okay. Now from there, we want to make Q naught minus Q the subject. So we're going to multiply both sides by CR. So we'll do that. So we're going to have CR times dQ over dt equals Q naught minus Q. Okay. Now from here, I want to integrate. Okay, so I have to take dq to this side and bring this on to this side. So if I take dt to this side over CR, I'm going to have dt over CR is equal to dq, okay, divided by Q naught minus Q. The next thing I want to do is integrate. Okay, by integrating, we are going to integrate from 0 to t, because initially at time 0 we don't have any charge, and to a final time t. Okay, why for this one? Initially at 0 we don't have any charge, so to a final charge q. Now even when I said the maximum charge is q naught, you notice that I'm integrating to q, not q naught. The reason why I'm integrating to q is because q naught becomes constant in the end. It is a fixed value, that is the maximum charge. Imagine the maximum charge of a particular battery is 10 microcoulomb, for example. It means no matter how you charge the capacitor, it cannot charge more, it cannot receive any amount of charge more than 10 microcoulomb. So that one is a constant. So we are saying from 0 to any value q, when t is having a value, q will be having a value. Okay, when t is now constant, or when t now reaches a final value, q now reaches what now? A final value, which is constant. That is why we're integrating down to q naught. Okay, so from here we're going to have, we integrate 1 over CR is a constant, so we're going to have 1 over CR. When you integrate dt, you get t, so you're going to have times t, and this is equal to, now how do we integrate 1 over Q naught minus Q? Remember I said Q naught is a constant, right? So it means when we check differentiating Q naught, so you're going to get 0, right? Now Q depends on Q, differentiate Q works with the Q rather. Differentiating Q, you are going to get 1, and there's a minus here, so it means you are going to get minus 1 when you differentiate the bottom. Okay, but we need to differentiate the bottom to get the top. That's integration. What I'm doing here is integration. Okay, so we can manipulate this right hand side and write it as minus integral 0 to q of minus 1 over Q naught minus Q times dq. Yeah, I think this one makes more sense. So you notice that when you differentiate the bottom, we get minus 1, which is 1 on top. So you take the lane of the bottom. So this is going to be equal to t over CR is then going to equal this minus out, so you have minus lane of the denominator Q naught minus Q. Okay, upper and lower limits. Now to do that, remember we're plugging these values for Q. We're not plugging it for Q naught because Q naught is constant. We'll put in Q first. We're going to have T over CR is then going to equal minus lane Q naught minus Q. That's what we're going to have at first. Okay, then remember we're subtracting because we want to put in the lower limits. There's another minus here again, so this becomes what now? Plus lane of, when you put 0 into Q, you get 0. So Q naught minus 0, that's Q naught. Okay, lane Q naught. Okay, now I'll do that. So come here and finish it up. So from here we'll have T divided by CR is equal to this becomes lane, applying the laws of logarithm, this minus this, so you have lane, this one, so you have Q naught divided by Q naught minus Q. Okay, we are done integrating. We want to make Q the subject formula. Now I can choose to turn this one upside down. If I do that, I'll have T over CR is equal to lane, okay, lane Q naught minus Q over Q naught, all to the power of minus 1. Okay, this minus can come to the back, so you have a minus 1 here. Okay, and then you can multiply both sides by minus, giving us the minus here instead and leaving here. Okay, so it's the same thing, it's just mathematics. Okay, I don't just want to spend time writing the different lines of these things I'm having, because I have just a very more space left. Okay, so from here I want to make Q the subject. I'll take the exponential of both sides. Okay, when I do that, I'm going to have exponential minus T over CR, and this is equal to this lane gets out, so you have Q naught minus Q over Q naught, multiplying, we have Q naught times exponential minus T over CR, and this is equal to Q naught minus Q. Now let's make Q the subject. If I take this on to this side and take this on to the other side, I'm going to have Q is then equal to, Q naught is constant, bring it out, I'm going to have 1 minus exponential T minus T over CR. Okay, now here is the formula for charging a capacitor, where Q is the maximum. Most persons think Q is the initial, Q naught is the initial and Q is the what now? Maximum. Please do not make that mistake. As Q naught is the maximum charge. Okay, do not make the mistake. Q naught is the maximum charge, while Q is the what now? Charge at any time t. So Q will be equal to Q naught into brackets 1 minus exponential minus T over CR. Okay, that is the formula for charging a capacitor. So whenever you are given a problem or question that involves charging of a capacitor, you see charging in that statement, your mind should run back to this formula. Now, how about you see discharge in that value or in that question rather? To discharge the capacitor, we're going to come to this diagram. Now, let's assume this whole thing here is now charged. It is now full. That is, the final charge of C is now equal to Q naught. What we're going to do, we're going to carry this key knob, open it, then connect it to point B, because we want to use the resistor as a means of dissipating the energy, okay, in the capacitor. That is current is not going to flow through the resistor. That is by connecting it to a load. That's what we mean by discharging the capacitor. And that is what we're having here. Remember, here is the plus and here is the minus. So we'll connect it. We're going to have a system. So this other part of the diagram is out. Okay, you can choose to clean this if you draw yours, and then we'll be left with this. And we'll apply the same KVL rule that we applied here before, which is Kirchhoff voltage rule. We are going to say the voltage across the capacitor, okay, that is the negative voltage because I'm moving like this, okay, of CV, then minus that of IR is equal to 0. That is what we're going to get. So from here we can say minus CV is equal to IR, okay, or you can choose to take the minus on this side. So we have VC is equal to minus IR. Now the current is negative because we are discharging it. So I could also use a different method, but I'll keep in mind that dq over dt, which is current, will be negative because I'm what now? Discharging, not charging. While in this case we had just dq over dt, not negative. Okay, so from here I know that I is dq over dt, okay, but I is equal to dq over dt. It means that VC is then going to equal minus dq over dt times R. Okay, now what will be the value of VC? We did note that Q is equal to CV, right? So we can substitute for VC as Q over C. So if we do that, we're going to get Q over C is equal to dq over dt times R. Right? I think this makes more sense. Okay, and there's a minus, do not forget. Okay, C over Q over C equals minus dq over dt times R. Let's make let's rearrange it and integrate. Okay, we'll do that. We're going to get Q over CR equals minus dq over dt. Okay, now let's try and rearrange so we can integrate. Now by doing that, we're going to cross multiply, so we'll be left with dq over q is equal to minus dt over CR. Okay, this is what we're going to have. This one comes in, this one comes in. They write this one first and take the minus to the other side. That's simple math. Okay, now the next thing you want to do is pay good attention. This is because when integrating, some persons will make a big blunder in integrating here. Now here is something you should take note of. When we integrate while charging the capacitor, we integrated from 0 because initially there's no charge in the battery or capacitor, and then there is now a charge of Q at any time t. It doesn't even necessarily mean that the capacitor must be filled. Okay, so it's now 0 from 0 to what now? To Q. Now when we come here, we are discharging the capacitor from a maximum charge, which is what now? Q naught, down to any value which could either be Q or 0. So you might want to ask, what are we going to integrate from what limit to what limit? Most persons will think we are integrating from Q naught to 0. No, it is wrong. We are not integrating from Q naught to 0 in this case. The reason we are not doing that is because we do not know if the capacitor will be discharged completely. Okay, there are some points that Q will be equal to 0, which is the what now? Final charge. Like if it is what now? Discharge, completely empty. You see, there are sometimes you use your battery, it's not completely down, you can keep it. Okay, but if I choose to put 0 here, it means what now? You're using the whole battery, okay, that you're having. So if I choose to integrate here, I'm going to have Q naught is Q naught down to what now? Q, and here I'm going to have at time what? At time 0 down to what now? T. Okay, because initially I'm not starting the time again. Okay, so from time 0 I start counting, then start discharging down to what now? T. So if I integrate this, I'll have lane Q. Okay, I'll have the lane of Q, upper and lower point. You have Q naught and then Q, and this is equal to, now this is minus 1 over CR. Okay, integrate, you get C. Okay, substitute the limits, you get the same thing. So from there we can choose to substitute, and I'm going to have lane Q minus lane Q naught is equal to minus T over CR. From here, we have lane Q over Q naught is equal to minus T over CR. Okay, taking the lane to the other side, it becomes exponential. So we have Q divided by Q naught is equal to exponential minus T over CR. We're making Q the subject. We get Q is equal to Q naught exponential minus T over CR. Okay, this is what we're going to get. So for discharging a capacitor, this is the useful or required equation. Okay, so if you are given a problem and the problem states discharging the capacitor or discharge a capacitor, what you are going to make use of, what your mind should take you back is to what now? This equation. If it's not something you can come, all you have to do is draw this diagram and derive it. Okay, now how about this one? If it's still not something you can come, remember, draw the diagram and then derive it. So for charging of the capacitor, we are having this guy. For discharging of the capacitor, we are having this guy. Take note that Q naught remains the maximum charge. Most persons think Q naught means initial, Q is final. No, Q naught is what now? Maximum charge. So take note of these things. Now here is how you see for a series of problems like this is being tackled. If you don't understand, all you have to do is rewind the video. Okay, as usual, rewind it and watch it a few more times so you can get a better understanding of everything I just talked about here. Okay, so that is it for discharging and charging of the capacitor. In our next video, we're going to be solving a problem on charging and discharging a capacitor. Okay, we're going to pick one of them or could either do both. Okay, so and also if you have a question, don't forget to put it in the comment section as usual, and like the video. Okay, if you're happy about it. Okay, and then even if you're not happy about it, as far as you learn something or it is probably new to some of you, so you might want to like and share with your friends. Okay, don't let them know. And click on the notification bell so when the next video is being uploaded, if you want to be first persons that will get notified. Okay, and lastly, subscribe to YouTube channel to help us to create more videos for you guys. Okay, see you in the next video. Bye.